Assalamualaikum. I back to all the lecturers. My name is Fithriyani binti Suhaimi. I am from EH2208H. So today I would like to present my research project 2. My research title is a review production of bamboo-based activated carbon via chemical activation with conventional and microwave heating method. Production of activated carbon had been studied in recent years due to the promising result of bamboo as activated carbon with high surface area. Bamboo-based activated carbon may be applied to be used for air treatment process and also water treatment process. Chemical activation is one of the methods to produce activated carbon. This study surveys the development of bamboo-based activated carbon via chemical activation, but focusing more on differences between conventional and also microwave heating during the activation process. Besides that, the comparison between the energy consumptions for conventional and also microwave heating method also being reviewed. There are three objectives that are being focused in this study. First, to study the effect of different types of activating agent that being used to produce activated carbon from various types of bamboo. Second is to investigate the optimum impregnated ratio, microwave power, and also activating time for various types of bamboo. And lastly is to compare the energy consumption between conventional heating method and also microwave heating method to produce activated carbon from various types of bamboo. So now for the problem statement, bamboo can be found abundantly in Asian country because it only needs several months to grow. Various types of bamboo, different activating agent, and different heating method can lead to different results of production of activated carbon. Other than that, the energy consumption of conventional and also microwave heating method is being considered in this study. As a result, based on Table 1, the physical properties of the activated carbon produced by microwave heating method with chemical activation, for bamboo from handicraft waste, it is reported by Liu. The author stated that the bamboo-based activated carbon that produced is affected by several factors such as impregnated ratio, microwave radiation power, and microwave radiation time. As for the impregnated ratio, the activating agent that being used is phosphoric acid. The optimum impregnated ratio that being used is 1. Based on this study, it is stated that as the impregnated ratio increase, the surface area of activated carbon increase. But as the impregnated ratio exceed 1, the surface area of activated carbon produced decrease. This may result from the excess amount of activating agent towards the precursor. The activating agent does not acting as creating the pores as it already becoming a disruption of pores due to excess amount of activating agent. For microwave radiation power, the author stated that the microwave power, as the microwave power increase, the surface area of activated carbon produced will increase. But as the microwave radiation power exceed 350 watt, the surface area of activated carbon decreases. This decreases of surface area may due to the disruption of pores because of high radiation power that being used for creating the pores for activated carbon. For microwave radiation time, the author stated that as the radiation time increased, the surface area of activated carbon produced will increase. But the optimum radiation time for this study is 20 minutes. But as the radiation time exceeds 20 minutes, the surface area of activated carbon that produced is decreases. This may result from the disruption and also the pores destroy due to longer radiation time. Based on this study, the yield percentage of activated carbon produced stated by the author is 47.8%, which is a quite high of yield production. As a result, based on this study, the surface area produced for bamboo from handicraft waste is 1,432 meters squared per gram, which is in the range of surface area which are between 1,000 to 2,000 meters squared per gram. Based on Table 2, the physical properties of activated carbon produced by conventional heating with chemical activation. For bamboo from handicraft waste, the activating agent that being used is phosphoric acid with impregnated ratio 1, and the retention time used for this study is 1 hour with temperature 600 degrees C. Based on the study, the author stated that the yield percentage for the production of activated carbon is 43.4%, which is slightly lower compared to activated carbon produced by using microwave heating by using the same precursor. Besides that, the surface area of activated carbon that produced using the same precursor and also activating agent is 1,460 meters square per gram. Even though the surface area is lower if using conventional heating method, but the surface area are still in the range of 1,000 to 2,000 meters squared per gram, which is result as a good surface area for activated carbon. For the energy consumption, most researchers stated that microwave heating method conserve more energy as compared to the conventional heating method. Therefore, in this paper, the calculation of energy consumption for both methods are being calculated. For microwave heating method, the calculation is based on general equation of energy, which is energy equal to power multiplied by time. The power is based on the microwave radiation power, and time is based on the microwave radiation time. The assumptions that being made for this calculation is no heat loss to the surrounding, and the heat transfer is in the form of radiation, and also the mass of precursor that being used is 5 gram. After calculating the energy need to be divided with the mass of precursor. Based on the assumptions made, the mass of precursor is 5 gram. Therefore, the energy consumption per gram of precursor for bamboo from handicraft waste is 84 kilojoule per gram. For conventional heating method, Stephen Boltzmann law is being applied in order to calculate the energy consumption for this study. Therefore, based on Stephen Boltzmann, it is stated that everything is losing or gaining energy. Therefore, heat is transfer of kinetic energy with no translation of motion in a solid, but there is a vibrational motion. This law is depending on kinetic molecular theory of temperature. The Stephen-Boltzmann law of the rate of radiation energy from the surface per unit area is proportional to the fourth power of the temperature of the body. Some assumptions are being made in order to use the equation of the Stephen-Boltzmann law. First assumptions are heat is transferred through conduction, convection, or radiation. Next is no heat loss to the surrounding. Next is the steady state of temperature, since this theory is depending on temperature. Lastly is the body need to be in an opaque. For the sample calculation, the data used was taken from bamboo from handicraft waste with temperature 600, retention or heating time is 1 hour, and surface area is 1416 meters square per gram. The radiation of energy per meter square area based on Stephen-Boltzmann law, the results are 118,567.46 kilojoule per meter squared. And in order to find the energy consumption per unit gram of precursor, the energy needs to be multiplied with the surface area. This results in 167.89 times 10 to the power of 6 kilojoule per gram. Based on this result, we can conclude that microwave heating method conserve more energy compared to conventional heating method, as the range of energy used is too large. This may due to a longer time needed when using conventional heating method compared to microwave heating method. As a conclusion, bamboo can be used as a source of activated carbon with high surface area. The properties of activated carbon depends on the type of precursor, activation method, activating agent, and process condition such as activation temperature, retention time, and impregnated ratio for conventional heating, while for microwave heating method, their process conditions are microwave radiation power, microwave radiation time, and impregnated ratio. The optimum experimental condition for conventional heating method to produce bamboo-based activated carbon, the activation temperature is between 400 to 800 degrees C, with retention time between 1 to 3 hours, and the impregnated ratio that are suitable for conventional heating method is between 0.5 to 2. The optimum experimental condition for microwave heating method, the microwave radiation power is between 300 to 700 watt, with radiation time between from 5 to 20 minutes, and with impregnated ratio 0.5 to 2. And as for the energy consumption, it is found that a microwave heating method gives a lower energy consumption compared to conventional heating method. These advantages imply to the production of activated carbon from microwave heating because of economically. Last but not least, I want to thank my family and my supervisor, Madam Fariza Hamidun, for guiding and also supports me in order to finish this research project. I think that's all from me. Thank you.